Hello, my friends. Roger, Mud Falls University, talking about the Great Pyramid in Giza and what is its purpose, how was it constructed, all that stuff. Now, I am going to present a new theory that speaks of the chemistry difference between the casing and the internal structure, creating literally a solar collector. Now, this is what and I'm going to explain all this in very quick detail, and then I'm going to go over it in extreme detail in another video. But this is what I can show, I believe. How were they built? I can tell you that they were built from the top down, from standing up structures. I have maps and so forth that show this from long ago. They knew about this. Did they create power? That's what we're going to discuss in detail. What were they made of? I can understand that, and I can discuss that in pretty good detail. Although there are some details that I don't know that much about, which is the casing stones, and some other things I don't have deep details about, but I have enough to start a theory. Now, how is the king's chamber possible? I fully understand that. The king's sarcophagus, it couldn't even get into the chamber. So they come up with some concoction to figure out how they did it. Anyway, why are there two different types of limestone? The inside limestone is 100% different than the outside, and I will explain that in great detail. Why? Well, forget the Sphinx. The Sphinx head and the material inside is the same material, but that's not of any importance at this point. What evidence exists? And that we are going to discuss. Now, we're going to go from there into the actual chemistry of how this works. Now, I'm going to explain that right now. Again, completely theory at this point, or hypothesis. No real evidence to support what I'm saying, except I think it makes sense. Now, the outside casing here is CaCO3, it's calcium carbonate, of the clear marine variety, nice clear white calcium carbonate. Now, inside, however, is a marl, a mix of all kinds of different stuff, and it's not all. This wasn't all blocks, and it's the outside is CaCO3, the inside is calcium magnesium, and then CO3 2. So the chemistry is different, and Ca magnesium. Calcium magnesium, very, very reactive stuff. You see this right here, calcium magnesium right here. You use this in growing plants and things. Very, very reactive in biological chemistry. And that is what we're talking about, is biological chemistry, because that is biology. I'm going to show you a video from the Science Channel that shows them explaining what is inside and what the capstones are made of. Only take a second. Now, pyramid means fire on the inside. Now, there's these chambers, and they just found another one up here. They didn't really ever know existed. I found it 2 years ago. It's 100 feet long, huge. They don't know what this is all about. The king's chamber is like an unfinished sarcophagus. They didn't just throw that in there. You know, the way they did things, they didn't do it that way. And finish everything else perfect. Some guy says, oh, they must have dropped it in the river on their way up and threw one in there for just silly stuff. Anyway, there's, as you can see, there's all these passages running down into a subterranean chamber, which is the well, they call it, and this descending entrance, and all this business going on in here. I'm seeing grounding. That's electrical grounding. Now, if I am right, and I could be not, this reactive calcium and magnesium, they're +2 molecules. You see this here? Calcium, magnesium right here. Very reactive. Lithium, sodium, that's serious stuff. Hydrogen. They're right in this serious down range here. So they have a lot of ability to work with electrons. That's what these things do. Lithium stores a ton, lithium batteries. Sodium, very, very reactive. And so down in this area, they have the ability to work in a lot of molecular things. Now, I'm going to show you our light experiments, and then I'm going to leave it at that, where it shows it can blast through these barriers. Now, if they could put a one-way sealer on here, you know, like a one-way mirror, you look through it and the light doesn't come back, then when they look in it, it reflects back to them. If you could get that light to go through there and then not come back, and that's all in band gaps, which is electronic orbital distances, and they are working in that range now and starting to understand this. Because I thought calcium, CaCO3, very, very white, highly reflective. I'm thinking, you know, because heat is nothing more than electrons. Electrons flowing into something is heat. That's what it causes, is heat. Now, when they radiate out, it keeps it cooler. So I thought, ugh. But anyway, we're going to get into all of that stuff, because I think there's a way around that once you break through these band gaps. And they're up in the 4 or 5 different band gaps. They're getting up to 50, 60. They're talking about 80% harvest of light. If that's true, that's pretty damn impressive. But anyway, you'd have to insulate the base. Well, you wouldn't have to, but you should. And then somehow all of that stuff flowing in flows through this chemistry, which is the same chemistry that's in your body. And this is the same chemistry that's in your body too, CaCO3. That's tendon stuff. This is all body chemistry. And I understand that. And you will too, because I could show you the scientific journals that, well, I'll show you one quick one. I'll show you the quick light, and then I'm off the case. All right, even if you don't have any chemistry at all, I'm going to make this simple. CaMg, that calcium magnesium, is what's inside the pyramid. On top of it is CaCO3. Now, the CaMg inside wants electrons. It wants electrons. That's what we need to flow down to the earth. They are p-type conductors. You see that? All 3 compounds, the CaEU and rubidium, all 3 are p-type conductors. That means they have a ton of extra holes for the electrons to flow right through them. That's what it means. All right, I'm just going to make this easy. Well, I don't know how easy it'll be, but there's a Hall effect, it's called. And I'm just going to read to you. It talks about voltage differentials and all this business. But basically all it means is the Hall coefficient is defined as the ratio of the induced electric field. And that means when electric current passes by something or into something, it induces a field. And I will show you these fields, because we can see them. You can actually see them. So it's the ratio of the induced electric field to the product of the current density and the applied magnetic field. Now, let's get a little confusing for most people. It is a characteristic of the material from which the conductor is made. Exactly. So it's the magnesium, the calcium magnesium, is the material from which that conductor is made. Since its value depends on the type, number, and properties of the charge carriers, which is the magnesium, calcium, which is a positive charge carrier. It wants negatives. It's a positive, and it carries the negatives through it. And it constitutes the current. How much current can it go through there? These are reactive substances. These are down in the areas where they carry a ton of current. And, you know, I'm not guessing at this. I did this stuff long ago. And you know, this was when everybody was just trying to figure this stuff out. So I'm not guessing at any of this stuff. Well, I'm guessing. You know, I am guessing at some of it, but I'm guessing this with some knowledge behind me. I'm not just guessing, saying, "Oh, this must be, this must be." No, what I'm saying, I'm showing. I have evidence to support what I'm saying. So I'm going to leave it at this for right now. But I'm going to get very, very deep, and it could be. There could be something to be learned from this. I don't even know if it's real, because there's going to be some kind of step downs in band gaps that, don't worry about it, but there's something between these 2 layers. I don't think they're just going to be together and everything's going to work. Something has to be like a membrane for it to go through. And I'll show you what I'm talking about in light experiments. All right, I'm just going to go with this. They're talking about magnesium and problems in strength, muscles, and nerves, and everything, because they transfer electrons. Magnesium plays a very important role, a across several different body systems because it's all got to do with electrical, including muscles because they contract from electrical impulses, nerve functions because that's electrical conductivity. It helps shuttle calcium and potassium ions, which are electrical impulses, across cell membranes, which is the membranes I'm talking about, pushing them in so they can't come back this way, which is required for healthy nerve impulse conduction and muscle contraction. Simple as that. And that's about magnesium deficiency in your body. So these are systems that work to create power in your body, the same as I think the pyramid. Okay, everything fits together, my friends. We're looking into magnesium, and look at this. I start looking into the different types of magnesium, magnesium sulfate and magnesium citrate. Well, what's the difference? And then all of a sudden I realize magnesium sulfate is Epsom salts. Well, guess what? I have a friend that has an autistic child that when he was suffering from the serious autism, she used to put Epsom salts in his bath water, and he would try to drink it because he's looking for the magnesium sulfate, which has all long been a boon for athletes. It's really anyone with sore muscles, and he knew to drink that now, and he had all kind of problems with his urine and feces and all that, and I think she's getting it under control with a couple of little simple things. You know, he was extremely on the heavy end of the autism spectrum, so we're looking to see how that works out. But anyway, then you go into magnesium citrate, and that is a different construction of magnesium, and that one they say is citrate. Might sound familiar. Consider an erudite way of saying that it's derived from citric acid. In the case, magnesium salt is obtained from citrus acid with excellent bioavailability. That means it just goes right into your body. This is the efficacy with which a substance is absorbed and used by the body. It's no wonder magnesium citrate, one of the most highly recommended magnesium sulfate supplements to health professionals, often used to naturally support digestion, specifically to alleviate constipation and acid indigestion, and it's also bonus points, easy on the wall. However, it may lead to dehydration, and the imbalance of minerals that arrive with this. Now, I don't know about that, but I have it. I haven't been taking it. I get all these things, you know, from my research, and then I don't take them. But I had them. Okay, you're going to say, well, calcium carbonate doesn't conduct electricity, and that's correct. However, it does if it's wet. As a solid, calcium carbonate is a poor conductor compared to metals. In solution, as ions, it is as good as conductor as most salt solutions, which are electrolytes and used extensively in electrical conductivity. Now, I will show you why I think the surface might have been wet. Now, as you, I hope, understand, my claim is that this was erected from a huge structure like this, a foot, let's say, or whatever it was. And these were all chunks of stone, which is the limestone blocks, and it would have been supported by a blood supply, which is an arterial supply. Do you see these things here? You see that? You see that? You see that? That looks like that is eroded to me. We know they dip in this way, and if the water was run down here and sort of sprayed over there, whatever they did, but if they could have kept that outside surface wet from a water spray here, that would have accomplished the conductivity that I'm looking for. All right, I want to just make another statement here. The Sphinx, if you've been following this Egypt area here, the Sphinx has a tremendous amount of water erosion. They said, oh, it must have been huge amounts of extensive rainfall. Here it is right here. The Sphinx, main type of weathering evident on the enclosure walls of the Great Sphinx was caused by prolonged and extensive rainfall that would have predated the time of these guys, because nobody knew about it, so it had to predate them. But if the pyramid was soaking wet all the time. Well, extended and extensive and prolonged rainfall. No difference whatsoever. Now, I've been going through this old map, and it's called Babylon, Egypt, which is where the pyramids were, and there's text in here I can't make out. So maybe somebody could figure this out. But at any rate, well, I'll just focus in real quick on that text up the top, so if somebody could see what that might mean. Just stop it and take a screenshot of it or whatever you do, and let's go into this. Because down at the bottom here, well, let's do the bottom one too. Alright, let's start right there. It's a little hard to see, actually. Let me focus in on it a little bit. Bring it over. And if anybody can shed light on what these things are saying, that would be nice. I had another map that I put up somewhere, and one of the things it said was, "Beware dragons in this land." And it was exactly what I was hoping it would say. Okay, now, this is kind of interesting. Look at all of these. They look like tree stumps. Now, what are they? I don't know. I don't think they're tree stumps. I looked at the inside of the pyramid on a show they did showing what the inside of the pyramid looks like, and I believe it's a bloody mix of a creature's body parts. I don't know what body parts. Originally, I thought it was like Devil's Tower, but I have backed away from that. I won't get into that right now, but I will later. Now, look at what you're looking at here. All of these, and they're right in a row, lined up against the Nile River. Now, this, I believe, is a channel coming in off of the river to bring into deliver things to the pyramids. And you can see them all over the place. And that looks like the Sphinx. I don't know, but it doesn't look like a lion's head. And then you got all these pyramids. They're all over the place, and they run down the line here. Now, so my contention is that yes, they are built on these plateaus, but the place where they built them was they built down from the plateau down. So they moved the stuff around and left these structures sticking up. That's how I am going to go with this, and I'm going to show you another couple little things about the erosion, and there's something else. Hold on. Okay, this is the Great Pyramid again, and don't forget, I'm just a guess that there was water flowing down these surfaces, making it conductive, number one. Secondly, making it cool the surface, and at the same time it would have an enormous amount of cooling in this general area. Now, as I said before, I am believing that this is built on a biological body part. What it is, I don't know, but body parts are supplied with water. Water comes through arteries. Arteries are wide open tubes, and the creatures the size I'm talking about, they are enormous tubes. Now, those tubes evacuate because those tubes have no restrictions in them when you lose the pressure of the blood pressure in your body, and they literally flow out, leaving an open tube, and they are called artesian wells, arteries, artesian wells. And what happens is water automatically just flows up through them. When the Nile was right close to the pyramids. Secondly, the erosion factor at the base of the Sphinx, and I don't know, but it looks to me like there's some kind of change in the outside surface here. As you can see, something looks different. I don't know, maybe they can look at that, but it's that way all the way around. So Is that just because they took these last blocks off mostly? I have no idea. Is it because there's some erosion factor? I have no idea. Somebody's going to have to be on site to look at that. And somebody should try to see if there was ever any evidence that there was any water coming out of here. Because, this cavitation here, this little cut here, would keep the water in between these surfaces. And, if it was me making it, I'd let them run down this edge and just dribble down the sides like this all the way around. And it would tremendous cooling factor around the edges. And people might be able to get their water over here too. Who knows? But at one point, the Nile was much closer. It appears, and I have seen a lot of documentation and pictures and things of that nature, that at one time there was a lot more water in this area and close to this. All right, now this is, I can't be certain what I am seeing here, but it was sent to me saying that this is what is down deep inside the pyramid, inside. People aren't supposed to go here as far as I know, so I don't know if this is true or not. But I understand what I'm looking at here, and that is, there's a lot of different, what's called layered intrusions. Layered intrusions are not just layers, something, sediment here and another layer and another layer. Layered intrusions, for the most part, there are some sedimentary areas, absolutely, but for the most part, when you see different materials, a layer of this and a layer of oxidized, red oxidized stuff, and then a layer of whitish looking stuff, and then a brown layer, and then a red layer, that is not from sedimentation. It is from a creature's body. And that is the kind of thing you have here. And somebody has removed things out of here to get down to this deep well area. For what? I don't know. But if there's a deep well in here, I can tell you what, that was an artery. I don't care what anybody says. Now, that, in my mind, would go all the way up through to the top. And at one time, it may have flowed water under just groundwater pressure. And that's what causes artesian wells to work. They just go all up to the top. Nobody has to put a pump, nothing. It's automatic because the pressure in the ground is so extreme, and if the water level was so close to the pyramid at one point, fairly close, you'd have extreme water pressure. So, just a hypothesis, just a guess, just a muse, let's put it that way. But it's as good as anybody's got as far as I know. Okay, these are the casing stones, and they're white limestone. This is a different internal, just a marl, and I will explain this, and I probably have either not before or I will. But they're two different materials. Now, these are gone, so you really can't do too much. I can't see too much about these. There's a few of them laying around apparently. I would love to know what exactly they were made of, and if there was anything on the internal surface, like to designate some form of a layer between these, to give it like a membrane, let's call it. All right, now here goes.
And so here, clinging to the pyramid, are these very irregular pieces set in great globs of mortar.
All right, when he says great globs of mortar, a lot of those are in blood and so forth. I understand these very well. That is all biology. Watch.
Just as fill, and you can see it. You can see the slump.
That's not just as fill. That is biology. This is biology.
Factor in the pyramid.
All right, now, once my claim is there was a structure, tall, sticking straight up, something like Devil's Tower, or it could be whatever it was. And now I don't think it was a foot. I originally thought it was a foot. Now I have a different idea. I'm not going to talk about that, but it was a towering structure. They took it and broke it down until they got it to a pyramid-looking thing. Then they sculpted the outside with these dressed stones that it gave support for where they were going to put their finished stones. The finished stones are the CaCO3, and I believe they kept them wet, and they somehow transferred the electrons that they absorbed through their ionic exchange, which I'll show you light and how it happens, into that inside, and then down through to ground, and in the middle they did something. They used that power for something. I don't know. This is just all guesses, absolute guesses. It's the start of a hypothesis. Nobody understands this. Nobody knows what's going on. So don't laugh at me because I'm coming up with a hypothesis. Thank you. Now this is nothing more than light, and it's breaking through something similar to a membrane. Now let me show you another set of lights. Now I do extremely deep light research. That is light. Now that got sent to me from a friend over in Polynesia. That is the concussing light that's hitting the water molecules, sending off concussed Higgs fields. I have voluminous amounts of videos about this, showing it in every single phase. And I get into all of this when I go a little deeper into the light research. And this is very deep stuff. This is not puppy stuff. These are the particles. That's the spinning particle. That's called a boson, and it's sped up, slowing down. That means light speeds up, it slows down. These are Higgs fields, exactly identical to what CERN makes. Not only that, from what I see, that's the particles of light, and if they were heavy particles, they would do exactly the same thing, crushing into each other's regions, because heavy particles own same kind of regions as these do, only bigger, and when they forced, this is charge separation in my world. You see these black dots? That is the difference between accelerated charge separated light, as far as I can tell. This is all negative in my world, and the black comes back in. I don't know really even what that means, to be perfectly honest with you. There's got a lot of research to be done here, but if we could get charge separation with heavy particles, when it came out the other side, we could make helium and end up with a ton of extra electricity. It is called fusion, and nobody's ever has any interest in this that I can find. Just to make my point, that's Higgs's fields. They're using particles 8,000 times bigger than ours. We're using one particle. But our single particles are identical to their little tiny puppies. These are the bosons that sizzle in little white strips, and then they smash into the field. That is a backwards particle. It even could be antimatter, for all I know. See that? That little white spinner came backwards. There it is right there. That's some kind of an impact. I don't know. It came through with some kind of structure to it. It hit one of these, and that's the only one that was like that. I mean, in this particular picture, that's the only one I've ever seen like that. All right, so we're going to leave it at that. I'm going to go real deep into electronics and everything, because the whole new theory is totally different than what they're saying. Absolutely, totally new electronic model, everything. And it accounts for everything in gravity. And gravity is nothing more than the attraction of a positive Earth to excess electrons in matter, and hydrogen and helium don't have enough excess electrons to be pulled to Earth, so they go up. Everything else comes down. The heavier, the harder it hits, because of more electrons. All right, so stay with me, and make sure you thumb this up and subscribe, and make sure you ring the bell. People tell me they're not getting their bells ringing, but I don't know. Do what you can. Stay with me the best you can. Drop in here and there. I post most every day. I decided I should add these just to give you a little more biology on the structures that I believe these pyramids were built from. Alright, this is not the exact same style structure as the Devil's Tower, which I'll show you in a second. This, I don't know what it is, to be perfectly honest with you, but it's very, very interesting shape. And these are blocks. I've looked at these very carefully, and they are blocks. Trust me, they're blocks. If you get in here real close, and you can see they are blocks. And that's in the top part is what's called an abrupt transition. I understand the architecture. Now, the water coming out here is coming out because of the same thing I'm talking about at the pyramid. An arterial network running down through whatever this biological part was. But these flat, abrupt transitions, and I'll show you the biology, why not? All right, we were just looking at Mount Roraima in Venezuela, and that is the type of blocky structure that's in there. Now, this right here is what's called an abrupt transition. It is flat as a pancake. Tendons come up in this blocky nature, and then they hit this area here, which is the abrupt transition, and that's where they snap right off. Now, that's just the way tendons are made. Now, I can't say for a fact it's a tendon, but it's something along that nature, or it's a muscle down there and the tendon was on top. I don't know, but it's got a absolute anatomical structure to it, and it is absolutely biology. It's got the red and the black and all that different stuff. Very, very obvious. It's pouring water out of there through symmetrically shaped, spaced arteries. There's no rocket science here. All right, I'm not going to get too crazy about this. This is the abrupt transition. As I talked about, all tendons break in an abrupt transition. This is an Achilles heel. This is the actual heel. That is the blood supply right there, and that's the blood supply right there. That is not from volcanism. None of this shape is from volcanism. These are tendon fibrils, and I'm going to show you the anatomical shots of this. The de-stressed tendon is here. These are normally highly stressed, which gives you the spring in your step. I mean, this is what it is what it is. And it's calcium carbonate. It's the same stuff that's in your body. The colors, these yellows and reddish looking colors are the slip clays that keep the fibers separated, and it's called fascially, and I'll show you that right now. All right, these are the tendon fibrils right here. You see these hex fibers? They run straight through all the tendons in your body, and they are tough, and they get to a certain place and they break off. It's called an abrupt transition. It starts to go into a different material in this tendon organ, they call them. Now, each one of these fibers is separated by a fascia, and that fascia is that yellow and reddish looking slip clays that are around some of these hex fibers. That's what's in Devil's Tower. Now, I don't think the pyramids are built on that same thing, but they are built on biology.